In the world of computer science, data is king. But raw, unorganized data is not very useful. That's where data structures come in. Imagine data structures as containers that hold and organize data efficiently. Just like a well-organized kitchen makes cooking easier, efficient data structures are crucial for building fast and powerful software. There are many different types of data structures, each with its own strengths and weaknesses. Choosing the right data structure can make a big difference in how well your program performs. In this essay, we will explore and compare two fundamental data structures: arrays and linked lists. By understanding their characteristics, you'll be well equipped to choose the best tool for your programming needs. An array is a fundamental data structure that stores a collection of elements of the same data type in contiguous memory locations. Think of an array like a row of lockers in a school hallway. Each locker has a specific number assigned to it, the index, and it can hold one student's belongings. Arrays are great when you need to access elements quickly and directly. You can access any element in an array instantly using its index, just like you can go straight to your locker if you know its number. Arrays allow direct access to elements using their index. Arrays are relatively easy to understand and implement. Arrays can be more memory efficient for storing large amounts of data. Arrays have a fixed size, which is determined when they are created. This means you need to know in advance how many elements you will need to store. Inserting or deleting an element in the middle of an array can be slow because it requires shifting all the subsequent elements. Unlike arrays, which store elements contiguously, linked lists use a different approach. A linked list is a linear data structure where each element, called a node, points to the next node in the sequence. Think of a linked list like a chain. Each link in the chain represents a node, and each node contains two pieces of information: the actual data and a pointer that tells you the location of the next node in the sequence. Linked lists are particularly useful when you need to insert or delete elements frequently, especially in the middle of the list. Linked lists can grow or shrink dynamically, making them suitable for situations where the size of the dataset is unknown. Inserting or deleting a node in a linked list only requires changing the pointers of a few nodes. Accessing an element in a linked list can be slower than in an array, especially if the element is located towards the end of the list. You have to traverse the list from the beginning, following the pointers, until you reach the desired element. Linked lists require additional memory to store the pointers that connect the nodes. Arrays versus linked lists. A head-to-head comparison. Now, let's compare arrays and linked lists across several key aspects. Memory allocation. Arrays require a contiguous block of memory to store their elements. This can lead to memory fragmentation if there isn't a large enough contiguous block available. Linked lists, on the other hand, don't require contiguous memory allocation. Each node can be stored anywhere in memory, and they are linked together using pointers. Access speed arrays provide constant time access to elements using their index, making them very fast for retrieval. Linked lists require sequential access, starting from the head and following pointers. This makes accessing elements in the middle or end of the list slower than arrays. Insertion and deletion. Inserting or deleting elements in the middle of an array can be slow as it requires shifting subsequent elements. Linked lists handle insertion and deletion more efficiently as you only need to change the pointers of a few nodes. Choosing the right structure, making the best decision. So, when should you use an array, and when should you use a linked list? Choose an array when you need fast access to elements, you know the size of the data set in advance, or memory efficiency is crucial. Choose a linked list when you need to frequently insert or delete elements, especially in the middle of the list. The size of the data set is unknown or may change frequently, or fast access to individual elements is not a primary concern. Conclusion: arrays and linked lists in the world of programming. Arrays and linked lists are fundamental data structures that serve as the building blocks of complex algorithms and software applications. Understanding their strengths and weaknesses is essential for any programmer. By carefully considering the characteristics of each data structure, you can make informed decisions about which one to use in your programs, ultimately leading to more efficient and well-optimized code.